Okay, I will share my screen then.
Hey, welcome. We're looking, yeah.
Thank you. Can you check that you are looking my full screen presentation? Thank you.
Yes.
Good.
Yeah.
Excellent. So I will be briefly in the first slides just to show you the music of space weather, because I know that this community is not aware probably of the importance or what are the observables, variables, and etc. that are interesting to analyze from VLab from a space weather community. Then I just show that the sun is the main driver of all the effects on the geospace, in particular in the upper atmosphere, but also in another parts of the geospace. And they produce a lot of consequence in different subsystems, mainly in technological and space systems, and also in communications from satellites. So in particular, I will show this slide that show that the sun produces radiation in different wavelengths, and each kind of radiation produce different effects on the upper atmosphere, in particular ionization in the upper atmosphere, producing changes in the ionosphere. And this produce a significant and in some point dramatic changes of the properties of propagation of radio waves that are used for communications in different levels. For instance, for geolocalizations using GNSS as GPS, but also for communications from spacecraft to the control tower or whatever be the communications using radio. Also, the sun can produce eruption of mass that also can produce significant effects in the geospace. So looking the sun is the first stage that we need to cover from solar physics. This is another example of problems with communications and different changes on the properties of the media where radio waves are transmitted. So what is important for VLab, what is important for training, what is important for forecasting, for observers in space weather? Look in the face of the sun. This is one example. This is an example of a solar surface shown a magnetogram, which is a proxy of the magnetic field in the solar surface, longitudinal to the vision line. And each of these features in the sun shows an active region, which is a potential region of the sun where it is produced a complex structure that will be erupted in some point, and perhaps, depending on the direction, can reach the Earth geospace, producing this consequence. So analyzing this kind of images is one of the main topics that are needed to do to attack from training in space weather. This is another example. This is the same sun, but now showing a different property. This is in this wavelength, in 193 Armstrong. And this shows what we call coronal holes, which are the regions from the sun where the fast solar wind is produced. The sun is producing eruption, permanent flow of mass, which is called solar wind. And in some regions of the sun, this solar wind is faster than in another region. And this shows the black regions, which are holes, because you have not enough mass to make bright regions, and you see as black regions, are the regions where the fast solar wind is produced. So this is also another example of the importance of analyzing images from the sun to analyze and forecast or determine the conditions of the space weather. This is a movie also that can be analyzed as with some tools to analyze different sequence of figures, a movie. And this is I will repeat the movie. This is a CME, which is an eruption from the sun. And this is an artificial defect of the detector due to the radiation, the high energetic particles associated with this eruption that produce in the camera, in the CCD cameras, pollution and a lot of pixels with the errors. So these observations are aboard of spacecraft, are in the space observing the sun phase. Also, there are instruments in ground stations at ground level observing, but only can observe it during part of the day, and depending on the wavelength, only with pure days, so without clouds or some specific conditions, atmospheric conditions. But in general, these images come from spacecraft in the space. So this is a movie also showing the corona, which is all other kind of observation that we can do from the solar surface. So different phases of the sun, depending what is the wavelength that we can observe. We can observe different features, different physics, different properties of the sun that can help us to understand and to this is an example of different wavelengths that are associated with the hot regions, cold regions, and there is a deep interpretation of what are you observing when you observe in a filter of a specific wavelength. So this is an example that we presented with Joaquin in the last meeting in Brazil, in Colage, 2 weeks ago, I think. My memory is not so good for short term, but more or less. And we produced a briefing showing the conditions of this week of the meeting in join with the different countries, Mexico, Brazil, Argentina, and Chile. And this is an example of other observables that are of interest. This shows time series, also observed from a spacecraft. These are time series observed from the solar wind properties observed in situ in the spacecraft. So you have the sun, you have the spacecraft before in the solar wind, before the solar wind arrived to and reach the geospace. And this spacecraft, for instance, these are ACE observations, observe in situ the real properties of the plasma and the magnetic field and can predict in short term, like nowcast, in half an hour or 1 hour, depending on the velocity of the solar wind, what are the impact expected in the geospace. These are magnetic field angle, velocity of the solar wind. These are the different colors, show the different, if the solar wind is fast or is slow. And these are the component of the magnetic field. Also images, yes, sorry. I understood that something is asking some. If you want to ask something, I am ready to, you don't need to wait to the end if you want to clarify some point. These are another kind of images that are also interesting to analyze, radio type 2. So this is artificial color because this shows emission in radio wave from the sun with radio observers in the ground station. And these are the coronal hole and active regions during these days. And this is the evolution of the surface. This is a product from Brazil, evolution of the surface of the coronal hole to see the slope, to see the trend, to see the forecast of how big will be the solar wind in the next days if you extrapolate this trend. These are also interplanetary conditions. And this is geomagnetic conditions. So this is a product showing the magnetosphere and also produce some images and some time series. These are images of some products. These are observed by GOES, and these are observed in ground station, the index DST, for instance, from magnetometers, which are also very interesting and very important to characterize the conditions on space weather. So this is a map of the electron content, and these are anomalies, also images that shows from some kind of instrument that can show what we call spread if in the ionosphere, that show anomalies in the behavior of the ionosphere that produce strongly distorted radio communication, radio propagation under these circumstances of the ionosphere. So all these images can be analyzed and need to be trained in space weather. These are also another time series, which are cosmic rays flux, which are linked with energetic particles arriving to different places on ground level, at ground level. So these are a detector in Antarctic, and this is a detector in Mexico. So UBA and SMN, the Servicio Meteorológico Nacional, are part of VLab, our Center of Excellence in Argentina, here in Buenos Aires. And this is a screen capture of the website of WMO showing these two institutions. And in particular, our group, which is part of the University of Buenos Aires, make different activities related with the space weather, but one of these is training, and we are part of Regional Training Center of Region 3 of WMO, and we typically give courses for aeronautics. We form human resources capacity building, forming master and PhD in these disciplines, and also we form forecasters, and we also give courses for the Air Force of Argentina and another kind of students from the region also. So this is a picture of our group, one of our offices, and we analyzing this kind of images and this kind of observation from satellites. We produce a bulletin, a weekly bulletin from this year, from 2016, producing the report of the conditions and the forecast of space weather, one bulletin per week. And we produce a briefing analyzing the conditions. This is just a summary of selecting courses that we deliver, but in particular, I want to emphasize one new formation of people in space weather that are making from the Servicio Meteorológico Nacional. I spoke a few days ago, and they give me this information to deliver in this talk, and they produce apps. They produce a permanent formation of new observers, more or less 30 people per year, from 3 or 4 years ago. And this, the concept is the following: they make a general formation of observers in different instruments, in typical and classical meteorological systems, and also including some instrument of space weather. In particular, the Servicio Meteorológico Nacional is taking activities on geomagnetism in space weather, not all the steps of the space weather. But in particular, once they have the background, the general background, when they select 3 or 4 or 5 people to go to Antarctic, and then they have a campaign to make specific observations, they give to these 4 or 5 people a deeper course. So they have 2 levels course, one general, which has a global concept, and then when selected people are ready to deploy in the campaign, in Antarctic in particular, for geomagnetic observations in Antarctic, in our bases in Argentina, they produce a specific formation deeply for this specific instrument. Okay, this is a selection. We cooperate with Tucumán, that has another center of space weather, and we interchange courses from Buenos Aires in Tucumán, and people from Tucumán giving courses in Buenos Aires to complement our know-how. And this is just a picture of different courses we gave in the last years. And this is a visit of Joaquin to Buenos Aires last year, this year, in April this year. It was very fast this year. I thought that it was last year. To our new headquarters. It is in a new building in Buenos Aires. These are pictures of the new building. It was inaugurated at the end of 2021. And this is an agreement that we signed between 4 countries in Latin America, called All for Space, American Latina League from Space Weather, signed from Mexico, Brazil, Chile, and Argentina, different institutions of these countries. So as main conclusions, I keep it this because probably I am a bit late in time, and I keep for questions now, or when Joaquin finish, or when you want, I am available to clarify or answer your doubts or questions. Thank you very much.
Okay, thank you, Sergio. I know I have a question, although it's for both of you. So how about we, unless there's a specific question to ask here, we can move on to Joaquin, and then
Okay.
Because I think some of the questions are going to be for both of you. So
Perfect. So I stop share and we can answer after. Thank you.
and thank you.
Mr. Kim, would you like me to share for you, or would you like to share yourself?
Please do it, because my computer is asking me to update something. So better
No
don't.
problem. Yeah, no problem.
Yeah, that's
Okay, good, excellent. Thank you.
Again, okay, you can start, and I will figure out again.
Can you put it in presentation mode?
Yeah, just a second. I'm today experiencing some issues with my two screens. So just a second. Okay, it's ready.
No, I mean, in presentation mode, you needed to click this icon at the bottom. That's okay. Thank you. Now my screen is full of. Okay, anyway. Okay, as Sergio already mentioned, the best part of the space weather, so observing the sun and the rest of the 150 million kilometers from the sun to Earth, I will focus more in the experience that you have recently and training people in space weather forecasting, and also show a little bit about the infrastructure that we have there in Brazil for training. Okay, this is where I say that we have a web page. We have there many products for space weather, not only for aviation. I will focus a little bit in aviation today, but we do have services for operation of satellites, for power grid lines, these high voltage lines, and other technological systems. But anyway, please go to the next slide, please. Just to make sure that you know what means, I mean, it's completely similar methodological services providers. But anyway, we do have fundamental research. So because we have to apply this modeling of these big spaces from the sun to Earth, how do they connect? We also use modeling, of course, not only from our group, from the community. We use high performance computer to ingest the data observing almost real time in this modeling, and then do some prediction if it's possible. It's a quite complex environment, as you may note. Anyway, but we do this, and then we provided this kind of services. We through alerts, information, and of course, if the end user feedback something for us, we can do the reverse, the research to operation to try to fix the modeling or think about what to do, right? So please, next slide. Okay, what this means? Monitoring, as you do in meteorology, analyzing and forecasting, right? We do have this daily bulletin in 2 languages there. Every day you have to analyze the environment and do some predictions for solar winds, solar flares, geomagnetic storms, well, many things about this kind of service. Anyway, next, please. Okay, now here I divided this big space in 6 different areas, because we do have different researchers in these different areas to make the analysis. This is because we don't have a kind of one model that you push the button and do everything for you. We can, of course, we have different expertise. This is the service that is being constructed. We're fixing the airplane on the fly, in other words. So, and then we need a specialist for an astrophysicist like myself, I mean, in terms of solar physics, to analyze the sun. And then we need somebody also in this sun and interplanetary medium to analyze the corona, external corona, and the rest of the space. I mean, different specialists are there watching this kind of variables that we measure in possible regions, not all the regions that we like, but anyway, in possible regions where we have satellites or the ground-based instruments can reach the point and tell you something. And then in these 6 areas are the sun and interplanetary medium, the inner magnetosphere, and radiation belt. That is almost the same space, but different techniques to make the analysis there. Ionosphere, neutral and ionized boundary, and ground-induced currents. I would say, yeah. geomagnetic induced currents. It's a bad word, ground. Anyway, and then you see, I put the faces of many of us there, the different groups of researchers that we have to make this kind of analysis. And this picture tells you more or less where we are. Okay, next, please. Okay, in terms of what's an operational system, it's something like this here in this block diagram. You have instruments in space or in the ground. You should receive this in almost real time, as you do in meteorology, for example. You do have one computer center for getting this data, well, applying the models and finalize some products and put this to your external output, like your website or your alerts that you send to somebody. And that's the operational system of this, everything that I'm saying here. Okay, next, please. In terms of researchers that I have there, I have, well, some six guys as a permanent position working there, but a lot of scholarship researchers that we have on this bottom here. You can see on the right to the bottom. And of course, technicians are third-party company to make all developments in terms of IT operating, and also some retired people that continue with us. We call them volunteers. And if you click the mouse now, you can see the staff that I have in the cloud, because I have different divisions working in the science of these areas here that I have also their participation in my division. I have a division for space weather there. Okay, please, next slide. This is needed because, as I said, we need the scientists to analyze the environment, because it's something that's not well understood yet in terms of how these affect the human life or technological sectors, let's say. In terms of computation, we have two clusters in terms of high-performance computing. We do have other computers for, well, the website and other developments that we have there. So please, next slide. In terms of a facility, we do have this room here, this office that we call the briefing room or the teaching room. We do use this place here to make our teaching class or teach our class, or even to have our weekly discussion about what we did do wrong in the last week. We called it weekly briefing, daily briefing. We do have and also a visiting center for, well, where we explain what is space weather means. Anyway, in the building you can see at the bottom. Next slide, please. This is where we have our ground-based networks. You can see our sky imagers in this. We're going to have now 7 points measuring this over Brazil. It's not updated here in this picture because we didn't install. I mean, it's being installed right now. Digisons will have 9, magnetometers 19, scintillation receivers 16, GNSS receivers. As we receive information from other countries around Brazil, we do have more than 500. Next slide, please. All right, now in terms of experience, recent experience that I selected here is, one of them was the Coast Park capacity building that we did in 2018. It was a very nice experience because we selected from 140 applicants. 30 students, again, they're balanced, also balanced in terms of continents. I mean, we did have people from Argentina, Brazil, Chile, Colombia, and a lot of other space, also in North America. We invited 14 specialists from outside. We had, for the main speakers or main lecturers, we had 2 tutors from our group to help them in this hands-on in the presentations. And it was a very nice experience. And we do have this kind of material, can practice this more. I mean, can offer this kind of training for the future. This was for one training for improvement of forecasting in space weather in general, not specifically one for one area. Next slide, please. This was presential, right? It was not virtual. Here you can see many pictures from 6 groups that they formed in 5 people each one. just to make sure that they learn what we taught and try to make a kind of analysis of the environment for a specific time that we selected to see if they did well. So this is the hands-on, some pictures, please, next slide. There in our briefing room. This is the guys that was responsible for this kind of class or teaching. We had more or less 3.5 hours for talks and 2 hours for hands-on every day for 2 weeks, for 2 whole weeks. Next slide, please. The next experience was more recent. We trained our airspace control department, not our, but I mean, in an organization that is not inside my institution, is some other institution, federal institution from the Air Force, Brazilian Air Force, that take care about this safety of the civil aviation. Due to the ICAO well, now there is an obligation to give these advices. I mean, for these officials that are responsible for the civil aviation safety, for using this space weather variables. We train them not to make the analysis of the environment because they are all meteorologists, but to understand what they are doing and what they should pay attention. And then this is the class that we did in our facility. Next slide. And then we complement this information with another section in their facility. I mean, the integrated aeronautical meteorological center that they have in another state, not here where I am. That's it. Next slide, please. Okay, we have a common products there for civil aviation that I used, the ones that are being offered by the global centers today. This is, for example, for Pegasus. I use this as a base for the information for training them. Next slide, please. I mean, it doesn't matter much. I mean, just to tell you, we wrote a PDF file for their training. So, well, I don't remember how many pages, but lots of us participate to writing this. It was in Portuguese, of course, but we are now going to translate it to English to make it more global, and then we can offer this course again. So next slide, please. This is in English, the index, but next one is what we have there in terms of, I translated here for you. Well, you can read this later. I can offer the PowerPoint to you. I mean, there's no need to go through this right now. Please, next slide, please. Okay, and our plan is, I contacted the people that is training at the INPE, my institution, the VLab for meteorological people, and they offer me this kind of Moodle platform that is good for making our presentations virtual. And they offer also one technician to help us to transform this material to these VLab instructions or virtual class. And our plan is in 2023 to use the training that we did for the aviation. This sector, we're going to start there to put in the VLab for including hands-on and things like that. So this is our plan. I think I finish here. There's one more, nothing. Okay.
Ernie, you're muted.
I'll say thank you. Thank you to both of you, to Joaquin and Sergio. I think between the two of you, you've answered some of my questions. And I think that's great that Joaquin, that I'm assuming you've either talked with Diego Sousa or
Diego was the guy, yes.
We know Diego, I think, is off on holidays right now, so otherwise he would be in the meeting as well. Okay.
I called him by phone. I disturbed him in his vacation. I'm in vacation also, but anyway.
Oh, okay. Well, thank you for presenting, both of you. And one And I do understand, or at least minimally, the impacts on aviation, especially over the poles. So are those some of the things that you go over in your training, especially when they're to aviation forecasters? Yeah.
Sure. We had three concerns in terms of aviation. One is the radiation levels at the height of the aviation. I mean, of course, across the pole is the worst part, but we are now measuring how much is the radiation dose for the heights of the aviation in Brazil, over Brazil, because we do have this summer region that is a region that where we expect to have, or we do have some information that we have particle precipitation there, a kind of particular aurora for Brazil. So then radiation level is important, one of the things. The other is the GNSS-based navigation and positioning that they use. So the disturbance in the ionosphere will disturb the communication from the satellites, GNSS satellites, to the receivers. And this makes your position very wrongly, I mean with some big errors, and then you need to know this. And also this ground, this satellite-based augmentation system can be disturbed by plasma bubbles at night or even solar storms during the day. Also, another thing is very problematic is the HF communication. They use the ionosphere as a reflector, and during the perturbation of the plasma bubbles and the solar storms also can be disturbed, and then they will be mute or they have a blackout. This is the three main things that we play with this sector. I mean, other are important for other sectors, but this is for aviation. Sorry.
Yeah, I would like to add, I fully agree with Joaquin, and I would like to add an example that an event that happened really, it was really very good, very well documented in ICAO, loss of communication completely in HF, and the plane was lost for the tower of control. They was not knowing where it is and if it is fall or it is planing or whatever, just because failure of communication. And even if in these situations the plane is going near a real storm of atmospheric and meteorological storm, the tower of control cannot communicate to anticipate and change the route, for instance. So it is very dangerous situation, and it happened. It is not a potential with extreme events. It happened in the past several times. And in particular, I was chatting with pilots, for instance, in the European Space Weather Week, and they told me that even if they don't need to change the route, even if they don't need to cancel the flight or to change the altitude of flight, just to be aware that the potential lack of communications is a 100% change for the pilots, because when you are a pilot and you are in the middle of the ocean going from Brazil to Europe, from Portugal or whatever, and in the middle you lost communication, you don't know what is happening, and you start to suspect that all the systems in the plane are failing, and you can imagine the stress situation and the bad decisions that you can take under these circumstances. So it is really very important to can provide this information forecast. And another comment I want to do is that ICAO is disseminating this information from the end of 2019 from ICAO to all the centers of aviations, in particular to Argentina, probably also to Brazil and to all the countries. But I know from Argentina is receiving and disseminated. And we need, from the training point of view, to train the decision makers, the pilots, the people in the airport, to understand this information, because it is not so well known, this kind of information. So they can receive a report, but what to do with this report? So I need, this is a gap that from training we need to fill in the world, but in particular in our region.
Yeah, this is what I'm doing with my officials here.
Yeah, exactly.
Okay. And I see a hand raised for Kathy Ann. I think it was Kathy Ann. Yeah, go ahead, Kathy Ann.
Are you hearing me?
Yes, go ahead.
Okay.
Yes.
Thank you, Joaquin and Sergio, for this excellent presentation and for actually answering the questions. Every time I write them down, your next statement is answering my question. So thank you so much. Let me first introduce
Thank you to
myself,
guide me.
Kathy. Yes.
Thank you.
Kathy Caesar from the Caribbean Institute of Meteorology and Hydrology, or Center of Excellence in Barbados. I'm also the co-chair of the expert team on education, training, and competencies under the Standing Committee on Aviation. And this is one of our main areas of interest, because one of our tasks is to advise on competency framework with relation to aviation operations on 3 areas: volcanic ash operations, space weather, and tropical cyclones. I will tell you of the 3. The one we know least about is space weather. And so this is one of the things I was really excited when our Argentina colleagues presented this at our last VLMG meeting. And I am really heartened by the fact that you all are putting a great interest in aviation, and suggest the same things that Joaquim just said. One of our, and Sergio as well, once this information comes out, we are aware that these documentations are going to start come out. Our concern, and some of the concerns of my colleagues in the region, is what do you do with that data? What do we need to do for our aviation community on that data? How is it going to be a warning? So for example, if you have a volcanic eruption, for example, we the VAC automatically puts out an area of warning. They put out where the ash will be, so the aviation flights are aware of that. Is it going to be something like that? Which will be very fine, because then the aviation community is quite familiar with that. It would be easy to either have something like what we call a SIGMET, a significant weather bulletin related to space weather. I think this is the way that you should go with that in terms of how you train. And so that would be one of the concerns. And the other concern that I would have, or question, in terms of for forecasters, and is there any other specific space weather competencies, let me put it that way, that they will need? This is something that we could talk about in discussions. I read your email. I read the email from Richard, to Paul, to actually come into one of the workshops in 2023. So this is something that we could talk about later on as well. In terms of putting together the framework, we can advise as the center, as the expert team on competencies, we can advise on the framework as well, since we have done that job as well. But I look forward to further discussions. These questions are something that we could actually discuss further, going further in 2023. But I think your presentation does answer a lot of the questions from beginning to end on how we could go forward. And I thank you so much for that.
Thank you. I just would like to make a comment. The difference with the volcanic ash, for instance, in space weather, you have different levels of alerts. It's not like there are volcanic ash and you need to cancel the flights, for instance. But in space weather, you can have a minor event that, as I mentioned before, just alert to the pilot, continue exactly the same, but the pilot knows that perhaps can be a lack of communication in certain range of time during the flight. But you have a lot of levels, and one of them in the other extreme is to cancel completely, because you will increase a lot the radiation, you will lose a blackout in radio communication completely, because the level of the event is very extreme. And in the middle, you have a different another possibilities. Some of the decisions can just change the altitude, because radiation depends on the altitude. So at ground level, you have not dangerous at all. At 10 kilometers or 12 kilometers, you have a certain level of radiation. If it is increased during an extreme event, you increase to a level which is dangerous. So perhaps traveling at 9 kilometers is a decision. For instance, if the event happened when you are traveling, for instance. Suppose it is sudden flare or sudden whatever that can't give you time to take a decision before landing. So you are already planing. So you can take the decision of flying, but a lower altitude. So there are different, or change the road. There are different. It is depending of the kind of events. There are a different freedom to react. It is a bit different to volcanic ash, which is more like binary, depending on the region, of course. But you cannot in the ash, you cannot travel putting some shielding or whatever. You need to cancel the flight. I guess I am not expert of volcanic ash, but
you got to cancel the flight. Yeah, so just one quick question then I have. Then you were saying it would be better for once you have these alerts to go directly to IQ rather than to a WMO watch office, which will actually have to then relay that back to IQ to the aeronautical offices as well. So that may be something to consider. It's not necessarily something for the meteorologist to know. They just have to be aware that the information should go directly to the IQ representatives or air traffic controllers. So that may also be something to consider for the future as well.
Yeah, probably it is a good idea. Yeah, thank you.
Thank you so much. But definitely, if you have my email, I'll put it in the chat as well, so I can keep in contact with you all, and we can communicate in the future. Thank you so much for this excellent presentation.
No,
Yes.
thank
Thank you,
you.
Zoya, for arranging.
Okay. And we have Yvonne has his hand raised, so we'll take hopefully a quick question, and then we may have to move on. Go ahead.
Yeah, maybe it involves politics, so it may not be a quick one. But if you can give a quick answer to what about the other countries in the region? You mentioned Mexico, Argentina, Brazil, and Chile or Peru. Do you have collaboration with the other countries in the region?
Oh, well, let me start. I mean, we start with these four countries because Brazil and Mexico was already in this. There is an organization called the ISIS, that is International Space Environment Services, that congregates all the regional warning centers. We are 21 around the globe. And then Mexico and Brazil was already, and Argentina was preparing to be. And then we get together, and Chile was together in one meeting, and they decide, okay, let's make this group one alliance, as we do have for aviation 9 countries or 10 countries in Europe called Pegasus, for example, right? But we didn't exclude the rest one. The 4 is all 4 space in our name acronym, but means we are now contacting Peru, and I'm interested to other countries around Brazil to participate. We start with these 2 because we were already prepared to provide the services. So then we provide the service for the whole Latin America, I would say. Our tech map goes from Mexico to Antarctica. So, and then we prepared a very standard map. That's it.
So the short answer would be you have to start from somewhere, right?
Yeah, we did.
Yeah, okay. Okay, good. Thanks.
Okay, and I'm going to add one other question because it's an observation. We have on our polar orbiting satellites, we have one of the visible channels is high resolution. It's called the day-night band, so it can see light at night. And I think you would be familiar with that. And so one of the things that gets people excited is, oh, they show pictures of the aurora borealis, and our forecasters quickly pointed out, yeah, but when that happens, then we can't use that imagery to see the features we want to see. And so is that used in your at all to look at, say, the distribution of some of the events? I was just curious. That was an aspect.
So
are you?
No, go.
Go ahead. No. I mean, go ahead, please. I did already.
No, just to clarify, the question is if it is possible to forecast the size of the aurora to match with your observation of lighting. I didn't catch exactly the question.
It's so we can see the aurora in this day-night band, and so that could be, some of the extent of it. Does that match up with some of your other observations, I guess is the question. So that's another thing that's readily available in, say, our display systems, and something that could be easily confirmed or not. Yes.
Oh yes, the aurora observation. Go now, you, Joaquin. Yeah.
No. I mean, it's perfectly possible to to forecast this because we observe this solar wind and coronal mass ejection in the L1 point. This is 1.5 million kilometers far from here. Is the gravitational balance between the sun and Earth, right? From there to here, according to the magnetic field direction, we can predict the size of the aurora. So you can say, okay, this you observe this kind of luminescence, night luminescence that is you're saying in the whole latitudes that is possible according to the measurement that we did in L1. So this is perfectly predictable. I mean, for hours at least, 1, 2, 3 hours ahead. I can tell you that this is going to happen. Also, we do the same at night in Brazil. I already showed you today in my presentation 6 or 5 points where we measure this luminescence at night in very dark